Hi everyone! In this video I'll show you how to enrich your CUBA application with visual representation for spatial data using the Maps add-on. Working with spatial data and displaying maps are essential for many business applications. But quite often, Java developers face the challenge of adding maps to their web applications. In most cases, it requires a developer to be familiar with front-end technologies, at the least, JavaScript. Even so, the implementation still may turn out to be complicated, full of boilerplate code, and highly time-consuming. The Maps add-on offers you an easy way to solve a wide range of tasks related to spatial data. It integrates spatial types from JTS Topology Suite, the most popular Java library for working with spatial data. It allows you to work with any map vendor compatible with the Web Map Service Protocol, or providing tiles in the XYZ format. The add-on comes with a UI component with rich and clear API for building well-structured maps of any content. It provides interactive tools for drawing and editing geo-objects and features for geo-analysis, heat maps, and clustering. The component supports traditional multi-layer structure commonly used in professional GIS systems. Layers can be of raster and vector types. In this picture, you can see the example of combining multiple layers to build a complete map. The bottom raster layer serves as a map's background. It can be a tile layer displaying tiles provided by the so-called XYZ tile services, for example, OpenStreetMap, or it can be a WMS layer displaying images provided by Web Map Services. The next layers are vector layers. They consist of geo-objects, which are entities with geometry attributes. In our case, the layer has districts represented by geo-polygons and customers with locations defined by geo-points. Now, I'll show you how to build a simple CUBA application with maps in 15 minutes. Probably some of you have already seen our petclinic demo project that can be found on the CUBA platform website. It demonstrates an IT system of an imaginary Pokemon's clinic with pre-filled data for clients, pets, vets, and visits. Let's use this app as a starter and extend it with the maps. First, take a look at its original data model. Owner is an entity that represents the personal data of pet owners. Pet contains name and birth date and is associated with the owner and pet type classes. Visit details are contained in the Visit class and are related to one pet. Vet is an entity containing veterinarian names, extends person, and is associated with the Specialty class. We'll extend the data model in the following way. First, let's add a new entity, Clinic. This entity represents a branch clinic office and has only two attributes, name and location. The location attribute is of JTS point type and represents the physical location of a clinic. Another new entity is district, which represents an area of a city defined by polygon geometry. Next, let's also add the location attribute to the owner entity as well as a reference to a district. Finally, we'll add a reference to a clinic in the visit entity. When a new visit is being created, the actual branch clinic office will be chosen based on the proximity to the pet's owner's location. What we're going to do is add maps to the editor screens for clinics, owners, and districts to enable interactive editing of the corresponding geometry. Also, we'll implement an algorithm that finds the nearest clinic for a client when they create a visit. In the Owner Browse screen, we'll add a map to display the owners with clustering mechanism enabled. Finally, we'll create a heat map to visualize the overall information about the frequency of visits in different areas of the city. Now, we're ready to start developing our demo application. Let's start by cloning the petclinic GitHub repository. Open it in CUBA Studio. We need to add the Maps add-on to our project. Open the Add-ons tab and go to Marketplace. Find the Maps add-on there and install it. If you don't have a subscription, you can get a trial version of the Maps add-on the Add-ons page at the CUBA platform website. Before we start adding maps to our application screens, we need to prepare the data model. Let's create the clinic entity. Add two properties to it: name of string type and location of geopoint type. Navigate to the Text tab to see the class source code. We need to add a couple of additional annotations to the location attribute. The first one is the geometry annotation. It marks the attribute to be used when displaying the object on a map. Another annotation is convert from the javax.persistence package. In this annotation, we'll set the JPA converter, which is needed to perform type conversion between the database and Java representation of the attribute. We'll use the CUBA point WKT converter, which comes out of the box. It transforms a point to a well-known text format string and vice versa. Let's add the location property to the owner entity in the same manner. Now, let's create the district entity. Add two properties to it: name of string type and polygon of geopolygon type. Navigate to the Text tab to see the class source code. Again, we need to add annotations to the property that represents the geometry. In this case, polygon, geometry annotation, and convert annotation. We'll use CUBA polygon WKT converter as a converter. Let's add a reference to the clinic in the visit entity. Next, we need to create a view for the visit entity that includes this attribute. Right-click on the visit entity and create a view. Name it Visit with Pet and Clinic. Set Visit with Pet as a base view. Add the clinic attribute and its location to the view. And finally, let's add a reference to district in the owner entity. And create a view that contains this reference. Name it Owner with District. Add the district attribute and its polygon to the view. We've made all necessary changes in the data model, so it's time to create the database. Go to CUBA, Generate Database Scripts. Click Continue to confirm that existing scripts will be overwritten. Create the database. Now we're ready to create screens for the clinic and district entities. Right-click on the clinic and create Browser and Editor screens. Repeat the same steps with the district entity. After we've created screens, we can run the server to see if things work properly. We can see that the newly created screens are listed in the menu. Now we can go on to adding maps to the screens. Let's add a map to the Clinic Editor screen so that a user can specify the location of a clinic right on the map. Open an XML descriptor of the Clinic Editor screen. Delete the location field as we don't need it. Add the GeoMap UI component under the form. Press Alt and Enter to add the add-on's namespace. Specify the main parameters such as width, height, zoom, and coordinates of the map's center. The center is specified by comma-separated double values of longitude and latitude. We'll be using Madrid as a city for our demo application, so we'll specify the coordinates roughly corresponding to Madrid's center. After that, you need to declare the layers. Our map will only have 2 layers, a tile layer as a background and a vector layer containing the current clinic. We'll be using the OpenStreetMap tile service for our demo, but you can use any other tile service by specifying a URL pattern and an attribution string, which some of the services require to add to a map. You can find the detailed information about tile services and web map services usage in the add-ons documentation. Pass the clinic DC data container to the clinic layer and make the layer editable to enable interactive editing of the clinic's location. Make sure to set clinic layer as selected layer of the map. Go back to the application. Create a new clinic. We can see that the map appeared in the screen. Since the clinic's location is not specified yet, the map is opened in the drawing mode. We can see it from the special crosshair cursor. Click on the map to draw a point. After the point is drawn, you can drag it or remove it by choosing the Clear Geometry option in the context menu. Similarly, let's add a map to the District Editor screen. Delete the Polygon field. Add the GeoMap UI component under the form. Press Alt and Enter to add the add-ons namespace. Most of the parameters will be the same as in the Clinic Editor screen. Add a vector layer with District Layer ID. Pass the District DC data container to the layer. Make the layer editable. Set it as selected layer of the map. Let's go back to the application to see the results. Create a new district. We can see a map added to the screen. Click on the map to start drawing a polygon and keep on drawing until you get the desired geometry. Click on the last added point to finish drawing. You can edit the polygon by dragging its points. It's also possible to add a hole inside a polygon. Choose the Add Hole option in the context menu. Then click on a polygon to start drawing a hole. Click on the last added point to finish. If you want to clear the polygon, choose Clear Geometry in the context menu. All changes in the geometry will be automatically saved after commit. Create 2 districts, as we'll need them later. You can see that the table displays the text representation of polygons. This column was added automatically as the screen was created. Since this representation doesn't say much, we can delete this column from the table. Go to the District Browse screen and delete the column. Now, let's add a map to the Owner Editor screen. Switch to the Designer tab. There are many fields listed here, so it'll be better to add a map on the right. To accomplish this, we need to add an H-box to the screen and put Field Group and GeoMap there. Add an H-box under the layout. Add Field Group to the H-box. Remember that earlier we added a reference to a district in the owner entity. Now we need to add the corresponding property to the field group. But first, change the view of the owner DC data container to owner with district in order to load the related district along with the owner. Then click on the column, then Properties, Add Field. Add District Property. We'll also need a data container for the district in order to use it in the vector layer. So switch to the Palette tab, click on the Data Components, choose Instance Container, and put it under the Owner DC container. Switch to the Properties tab and choose the district property. Generate the ID by clicking the button next to the corresponding field. Go back to the XML. Add a GeoMap component to the H-box. Select the main parameters: width, height, zoom, center. Next, describe the layers. The first one will be a tile layer. The next one is district layer, a vector layer that displays the related district specified in the corresponding field. The layer will be refreshed as the value in the field is changed. The owner layer contains the editable owner instance, so pass the owner DC data container to the layer. Make the layer editable and set it as selected layer of the map. Go back to the application. Create a new owner. Click on the map to specify the owner's location. Choose a district in the Picker field. Notice that the corresponding layer has been refreshed as we updated the value. Try choosing another district or clear the value. Up to now, we've been building maps only in XML descriptors, but you can also work with the GeoMap UI component and layers programmatically in screen controllers. For example, in a screen controller, we can customize styles for a point and a polygon. We can also add validation to check whether the owner's location belongs to the district. Let's start with the styles. Go to the Owner Edit controller. To customize geometry styles, you need to set a Style Provider function to a vector layer. This function calculates the style for a given geo object belonging to a layer. CUBA 7 introduced a very handy mechanism that allows you to specify such functions declaratively, with no need to call a particular setter method. For example, to define the style provider for the owner layer, declare set owner layer style provider method that returns geometry style and takes an owner as an argument. The name of the method is not important, but it should explain what the method is needed for. Add install annotation to the method. In the To parameter, specify the ID of the GeoMap UI component, in this case, map, then dot, and then the ID of the layer, which is owner layer in our case. In the subject parameter, set style provider. In the method's body, describe a style. In our case, just return a point style with a custom icon. Let's do the same with the district layer. Now we need our method to return a polygon style. And finally, let's add validation to check if the owner's location is inside the district. Subscribe to the pre-commit event. Implement the validation in the method body. First, check that the location and district are not null. To check whether a point is within a polygon, use the within method. And if the condition fails, prevent commit and build a notification with a corresponding message. Go back to the application and open the Owner Editor. You can see that the style settings were applied to the layers, and if we set the location to be outside the district, we'll witness an error message. Before we continue, we need to fill our application with data. Follow the link in the description below. These are two Groovy scripts with predefined generated data that can be imported into your application, so download them. Go back to the application and open the JMX console screen. Find the Scripting Manager bean by typing its name in the search field. In the root path property, you can see the path to the directory in the application server where you should put the Groovy scripts. Copy them to this directory. Run the import1 Groovy script. As the message says, the import finished successfully. Do the same with the import2 Groovy script. Now that our application has a sufficient amount of data, we're able to proceed further. Let's move to the next task. When creating a visit, we want to automatically set the nearest clinic to the pet's owner. To implement this, we'll use the power of the JTS framework, which provides a wide variety of functions and algorithms for vector geometry. Go to the Visit Editor screen. Change the view of the Visit DC data container to Visit with Pet and Clinic. Also, change the view of the Pet's DC data container to Pet with Owner and Type. add a clinic field to the field group. Next, create a data container that will be loading the list of clinics. Go to the screen controller. Subscribe to the event of changing the selected pet for the visit. Inject the clinic's data container and the clinic field. In the method body, we'll first check that the pet's owner location is specified. If yes, then we'll iterate through all available clinics to find the nearest one for the pet's owner. Otherwise, the clinic will have to be chosen manually by a user. We'll use the static method distance from the distance op class provided by JTS. This method calculates the distance between 2 points. Go back to the application and create a new visit. When we choose a pet for the visit, we can see that the clinic is determined automatically based on the algorithm that we've just implemented. The Maps add-on provides useful tools for geoanalysis such as clustering and heat maps. Let's use these features in our demo application. We'll start with the clustering. When opening the Owner Browse screen, it would be handy to see not just a table of owners, but also the locations of the owners on a map. We can also add an option to show the owners belonging to a particular district. Go back to the studio and open the Owner Browse screen and switch to the Designer tab. We'll reorganize the layout of the screen to place the map on the right. Add an H box with 2 V boxes on the layout. Correct the size parameters of the H box and V boxes. Move the filter and owners table to the first V box. Add a lookup field to the second V box. Specify an ID, district field, and the caption, District. We need to specify an options container that contains all available values for the field. To do this, first add a new collection container to the screen. Choose Class, District. Then set this container to the District field. Go to the XML descriptor and add a map under the District field. Set the width to 100% and set the expand parameter in the VBox to map. Add a tile layer and a vector layer of owners. Go back to the application to see the results. So that's how it looks when the clustering is disabled. There are too many points on the map, which not only looks untidy, but also leads to bad performance. To enable clustering, add a cluster tag inside the vector tag. In the cluster tag, you can also specify some additional options, but in our case, we just keep them default. The next thing that we're going to implement is filtering by district. Subscribe to the changes in the district field. Inject the owner's data loader. Create a load context to apply an additional condition, to load only those owners who belong to the specified district. Use Data Manager to load entities from the database. We also want to see the borders of the selected district on a map. We can achieve this by adding the district's polygon to the map's canvas. Canvas is a utility layer of the GeoMap UI component that provides a straightforward API for adding and drawing geometries on a map. It can be really useful when you need to display vector geometry on a map, but you don't want to work with entities that vector layers are working with. you can obtain the canvas by calling the getCanvas method of the GeoMap UI component. Create a variable that will store the currently displayed polygon. Use this variable to remove the polygon from the canvas when the selected district is changed. And finally, let's make it possible to choose the owner on the map and make the table automatically select the row with the chosen owner. Create a method that takes the GeoObjectSelectedEvent as an argument and subscribe to the owner's layers events. In the method body, perform selection of the needed item in the table. Go back to the application to see the results. Now we can see that the owners are grouped into clusters. Select a district to see the owners belonging to the district. Click on an owner and you'll notice that it's selected in the table as well. Now we can go on to the final task, creating a heat map of visits. Actually, this map will contain locations of the pet's owners, but the intensity of each point will vary depending on how many visits the owner had. So this map is supposed to give the information on which areas of the city are best suited for opening a new branch clinic office. Go back to the studio and create a new blank screen in the visit directory and name it Visits Heatmap. Switch to the XML descriptor and add the GeoMap visual component to the screen. Set width and height to 100% to make the map full screen. For the time being, we'll add only one layer with OpenStreetMap tiles. Switch to the designer. We'll need 2 data containers for clinics and visits. The visits should be loaded along with the pet's owner, so we need to declare a new view. Let's name it Visits with Pet and Owner. Return to the XML descriptor and add a new vector layer with clinics. Let's customize the appearance of the clinic points. Switch to the screen controller and add the method similar to the one we created earlier in the Owner Editor screen. Specify the hospital icon for the point and make it red. Now we're ready to add a heat map. Subscribe to the Before Show event of the screen. Load the data into the data containers by calling the getScreenDataLoadAll method. First, we need to build the Java map of pairs, point and its intensity value of double type. Inject the visits data container and build the intensity map, taking advantage of Java streams. Inject the GeoMap UI component and add the intensity map to it by calling the addHeatMap method. You can also set additional options for the heat map by initiating the Heatmap Options class, specifying the needed parameters, and passing this object to the method along with the intensity map. Restart the application to apply the newly created screen. Go to the Visits Heatmap screen to see the heat map. If we were thinking about opening a new clinic, we would find this visual information really useful. All right, we've done everything we planned. Join our community and feel free to ask questions. Check out other add-ons at the CUBA Marketplace. Consult the documentation on our website. Star us on GitHub and subscribe to our Twitter and YouTube channels. All links are clickable under the video. Thank you for watching.